Welcome to the next episode of Binalogy,
where I teach you biology
and I teach you analogy.
so you get it.
Right?
Today's episode is about meiosis. Meiosis is how your body produces its gametes.
Gametes are like the sexy celebrities you see on TV, except they only have half the brain you do, so you should feel proud because you're very smart. At least smarter than Kim Kardashian.
What she means is that gametes, aka your sex cells, only have half the number of normal chromosomes within a cell. They have 23 chromosomes instead of the normal 46. So this is why your gametes are known as haploid.
Oh no, we're talking about this one. Kids, please do not do the hanky-panky before the marriage, okay? Gametes have half the chromosomes we have, okay? So they come together and make babies.
Yeah, I was just getting to that.
It's very bad.
So the female gamete, the egg, combines with the sperm, which is the male gamete, in order to make a zygote. Now, the zygote is a single cell that continues replicating in order to make one organism. Now, the zygote contains both the 23 chromosomes from the egg as well as the 23 chromosomes from the sperm.
Oh, baby!
Exactly.
It's like when you're eating ice cream, okay? You take 1 scoop of vanilla and 1 scoop of chocolate and there you go, you have ice cream. But you should not eat ice cream before the marriage, okay? Very bad.
Kids, please do not wait until after marriage to eat ice cream. You will have a very sad childhood. So we already know that mitosis creates 2 identical cells, but how exactly does meiosis create 4 unique cells?
I don't know.
Well, meiosis is a 2-step process. So one cell divides into 2 cells, and then those 2 cells divide into 2 more cells for a total of 4 cells. However, meiosis is not called reduction division for no reason. The normal diploid cell is reduced to 2 haploid cells. So the original number of chromosomes goes from 46 to 23 chromosome cells.
Meiosis is composed of meiosis 1 and meiosis 2. In meiosis 1, the first step is prophase 1. In prophase 1, the nuclear membrane disintegrates and the chromosomes condense. Crossing over also occurs. This is when chromosomes exchange regions of genetic material with one another, and it like square dance. Okay, when you hold hand with somebody and you hold another hand with somebody and you exchange hand. I don't know how square dancing works. Okay, I want to do the Bollywood. Okay.
In metaphase 1, the chromosomes move to the equator of the cell. Next, during anaphase, the chromosomes move to opposite poles of the cells. Then, during telophase, the chromosomes condense at opposite ends of the poles. And then, cytokinesis is when the cytoplasm splits.
And that's the end of meiosis 1. But wait, there are only 2 daughters here. What about the 4th?
Well, we haven't talked about meiosis 2 yet.
Oh, come on. The script is already so long. I don't understand this one.
Worry about the sudden change in lighting. Our natural light source just kind of died, and we're in a basement, so we turned on a light. Yeah, it's raining, so it's cloudy and stuff. Yeah. During prophase 2, the spindle forms around the chromosomes, and during metaphase 2, the chromosomes move to the equator of the cell. During anaphase 2, the centromeres split, and the chromosomes move to opposite sides of the cells. Now, during telophase 2, a nuclear membrane forms around each set of chromosomes, and then during cytokinesis again, the cytoplasm splits.
So you take a piece of dough, right? And you split it into 2 pieces, so you got 2 roti. Okay, but wait, you don't have any more dough. And you don't want to spend more money on dough. So what you do is you take the 2 pieces you have and you split it into 2 more pieces. So now you have 4 pieces of dough, enough to make 4 rotis. Come on, you need more rotis, right? Right?
Okay. So, the process to create male sex cells is a lot different than the process to create female sex cells. The process to create male sex cells is known as spermatogenesis, And the process to create egg cells, which are female sex cells, is oogenesis. In males, the primary spermatocyte divides into secondary spermatocytes, each with 23 chromosomes. These then develop into sperm cells in order to proliferate a generation. Primary spermatocytes, secondary spermatocytes.
Kids, please do this.
Okay, we get it. Do this after the marriage, okay? Gosh, I knew the genetics unit would be awkward with
No
you.
respect. I don't get any respect.
Nope.
The eggs are produced in the process of oogenesis, in which primary oocytes divide into secondary oocytes. Except only one is made into a secondary oocyte, with most of the cytoplasm and nutrients going into one cell, and the rest of the cytoplasm going into a structure called a polar body, which can be used to provide nutrients for the second oocyte in plants. No.
Why'd you make me be the polar body? I see. No respect, okay? But at least in plants, I can be the food for the seed. Okay, I'm proliferating the generation. No.
Except, of course, anything can go wrong. So, during meiosis, you could end up with one cell having one extra chromosome or another cell having one less chromosome. And this is caused by non-disjunction, which is a failure of chromosomes to separate during meiosis.
That's like when you go to school for the first time and you don't want to leave your mommy, so you stay on their leg, okay, and you failing to separate, okay. So basically, you failed school, okay. I know this one because my son did this one, okay. He failed, okay, and he got very zero and everything. Disgrace. I don't understand this one. You dumb hand.
Jar!
Jar, why? I didn't make fun of Joe.
You called your own son stupid.
You see, I have no respect. I have to take my money and go all the way to the jar. Stupid.
An example of having too many chromosomes is Klinefelter syndrome, and this is when a male karyotype reads XXY instead of XY. So, a result of this is having the same fat distribution as a woman would, and also having the same risk of breast cancer as a woman would, because you do have those two X chromosomes. Now, you could have one too many chromosomes in one cell, but that also means that another cell has one too less chromosomes. An example of this would be Turner syndrome, where you only have one X chromosome.
It's like when you have too little or too many samosas, okay? When you have too little samosas, your stomach not full enough to do things, and then when you have too many samosas, you're too full to do anything, okay? But when you have just the right amount of samosas, you can do anything.
And that's today's episode. We'll see you next time
On
Binalogy.